Welcome back, guys. So, yesterday we left off. mm, Yesterday we left off here. So I was not. I didn't get any time to continue yesterday. So yeah, but still it's fine. But we have the following things. What is this? No, this is not the one. I think it should be inside core test. Yeah. And yes, what did we do yesterday? We tried to create a buffer that will be holding our bitmap array, and within that array we are gonna try to create a helper that's gonna allocate 200 bytes of a memory. And the first thing we have to do is we have to convert the 200 bytes into pages, because we can only allocate in terms of pages. And the condition is super simple. We just check if it's less than 496, because that's our page size. If it's less than that, we could just assign one page. If it's not that, we do some calculation and figure out how many pages we need to assign and call it there. So how does the function work? Function just iterates over it, the overall size, and tries to find free memory. It's just going to try to find the next possible free page, and it's gonna take and it's gonna allocate that page within the bitmap array, saying that it's already being used. And finally we have the find array and find free, which is the actual implementation that's going to figure out the next possible free index. And it's just going to check the index and check if the bit is set or not. That's all it's gonna do, and it's gonna return. So this is how we are planning to do it. And let's just run it to see if it works. If we go into desktop, kernel, mmu, simple mmu, cd core, and we can see if we have the gcc command. No, we don't have it. So no, it's not. It's clang. Yeah, it's there. And I believe it works because it didn't throw any sort of error. We could just try to see which index was allocated for this particular thing, and it should be fairly simple. We could just print f what do I type here? Found index percentage lu ld. It's a long integer, so it'll be index. We could also check the bit. How do we check the bit? We could just print it as x, I guess. X or p. P is for pointer, I guess. Let's see what's getting printed, and then we can figure it out from there. And now if we rerun it, it should be LLU. LLU. And if we, and what does it say? More conversions. Insufficient arcs? What do you mean? Okay, I haven't even passed bits. Okay, let's see. I guess it should work. No, it did not work. Because we didn't even reach that fucking print statement. So something is wrong. Something is definitely wrong. We're trying to check this. Let's see if we are inside the bitmap. And let's see if we are inside here. Printf. Set bitmap. Let's say LLU. And puts can't I. Okay, so we did reach the first index. And did we find the valid bits? Valid. No, we didn't find that. We just probably because we did not reach it. We also did not reach the second level. That's because we only have one here. And we only want to find one page, so that's fine. And okay, let's see if why our find free didn't work. Did not work. Did not. Maybe our fucking for loop is not correct. Are we inside here? I think our for loop is not correct. But why? But why? Let's just add this here. That way we could get it in one. So something is wrong. We are not able to get into the for loop. Oh, so even in the first statement, we will. Okay. So you just put less than or equals. I think it should work. What? Why? Index is already defined. Index is less than this. And we just should do a simple for loop. Why can't I write a fucking for loop? Why do I need starting loop. Let's yank it and paste it. Ending the loop. Okay. All of a sudden we found index. What the fuck did we do? We didn't do anything. Maybe it's this O2 that fucked us. It's possible. But we have found index and we check if it is valid and we return it and we have set it to true. Okay, so everything is working. Now it's time to check with multiple iterations. If we click these, no, how do we do that? Oh no. It's Control V and this and A1 escape enter. Fuck me. Okay, I fucking fucked it. I think we'll just go with the manual way. Yes, it is finding the index and it is able to do it. Okay, now let's just try till 8th because we also have to make sure of that. And the easiest way to do that is just put one here and take this and tuk. Now we can assign it as many as times as we want and let's see. 0, 3, 6, 7, 8. We reached till 8. Okay, we need to check few more times because we need to confirm if we are properly. Okay, everything is correct because after 07 we move to first index 0th bit, first index second bit. Okay, so our implementation is working. Now the hardest part, that is to do this. Just after we set bit is used, we also have to map the virtual memory. That's the key part. So let's do some research. What the fuck is allocate mem Linux? No. Allocate mem. Let's ask what does mmap use internally to allocate new pages. Okay, so they're just simply gonna modify the page tables. That exactly what we are also gonna do. But still, mm, let's see. The kernel needs to keep track of what are the physical pages that are currently in use. Which helper is used to achieve that? Primary data structure called struct page, which is part of memmap vector. Each physical page has a corresponding entry in the array, and the physical struct contains various flags and metadata, including a reference count that indicates whether a page is okay. They use reference counting. Okay, let's Google this. It's map. We want to check memmap. Ah, interesting. If we give a address and the page size, it will reserve that page. Hmm. I mean, I get the idea. I just want to understand one thing, that is, how does it do the page table mapping? Because I know it's we just take the current processes table that is within the address some register, and we can add the maps. But yeah, I just want to know how it does it. Get user pages, put free. Nope, nothing interesting. Page lock. I remember that name. Page lock. What do we do with page lock? Page lock. Lot of macros, lot of definitions that we fucking don't understand. I think we can use this name to get more references. Page log. Page allocation. Yep. Let's see. Chapter describes how kernel pages are physical pages are managed and allocated in Linux. This is exactly what we want. The principal algorithm used is binary body allocator, but I don't want that algorithm because it's like too big and it's not. I mean, we can implement that algorithm, but I just want because we already have an algorithm. This is our fucking algorithm. We are just going to search bit one at a time and we're gonna set it. What we want to do is just figure out the exact way they implement it. Allocation. Get free page. Allocate a single page and return the uh, see this is exactly what we want. So if we see the implementation of this, we should be able to see something. Huh? Get free page. Address is less than lower memory. Return address is greater than more memory. The free memory cannot exist. Address minus low memory. Map address minus minus. Map address equal to 0. Trying to free page. Minus minus return. What the fuck? I think this is what we have to do, but now I'm just trying to see where did they get the table of that process. We could get it from the register, but where did this fucking guy get it? Free page of memory at physical address. It's at physical address. Get free page. Okay, let's see. It's going to do move EDI, move EDI, move EDI. So it's also doing the same thing. It's just taking the last memory out of it. Okay. And they have allocated this as a paging pages. Oh, fucking hell. Okay, I think it's time to just do it on our own. But I think it's fine. It should be fine. It should be. Only thing we have to do currently is that um, we need a virtual address. So for the particular virtual address, we could map uh, a physical address, but that should be process specific. So that's not part of this particular helper, because this particular helper does not it should not be called directly from any user process. This is only for allocating pages. There should be a high level helper that is going to call this, and that high level helper is going to keep track of virtual to physical mapping. This particular fucking helper has to do only one thing, that is just allocate a free page. That's all. Allocate a free page or remove it. That's all it's gonna do. It's not gonna do anything else. Yes, I believe that would be better, because this is like a low level helper. There's no point in bringing in high level virtual addresses into this. I think even the part where we have to actually map the virtual address, because the virtual address has to come from either from the kernel level or from a user level process. So only then from there we'll get a physical address, we'll get a virtual address that needs to be mapped to a free page that we just got from this helper. So let's just take an example of the user calling malloc. So let's say the malloc comes down to a helper, and that helper is this the about that one we might write in future, and that helper will have a virtual address, and it will have the amount of bytes it wants. So it will then call our final helper to allocate this much of ram, and it will say that we have found 3 pages for you, and we are just going to return those 3 page indexes. Now the second helper can just map the virtual address to the physical address. I think that would be far better, because let's just leave those parts separated. And I think this should be enough. We shouldn't do anything other than this. Currently, we have everything perfectly done. We have the physical index. We have the index within the bitmap array. So no matter who calls this, we'll find a free page for them as long as there is a free page. That's it. Nothing much. Now we could also write the extra helper that is going to be removing that particular memory. So to remove a particular index, they uh, also one more thing. I think we should not return bool. We should actually return the index. Only then it will be useful in any way because we need the index. If not, how else the future helper is gonna work with it? We say we allocated something, but someone has to map the virtual to physical, so they need some way to find the physical address that was assigned. Yes. So what we could do is we could just return the index and the bit. Yeah, that would be better. Yep, yep. Yes, let's see. Instead of sending a bool, let's put bit index. And mm, okay, what if they want 3-bit indexes? What then? Okay, we have the size, so yeah, we could just say we'll be returning a bitmap array. We could give it like this, and we could allocate it. How do we allocate it? Bit index star arrays equal to maybe we can add the size here. And the rest of I equal to val. Everything is stack allocated. That's not good actually. Hopefully everything will be passed by value and not passed by reference, because it's integer and bit, so probably it's going to be passed by value, not reference. In that case, I just have to bit index array. So it will be values, not references. And finally, we could just return res. And no, we don't need this logic. And here we written the same thing. We put it as bit index array, and we get bit index here. I think it will say that bit index versus bit index sized array, something like that. I don't know. I think it's not even proper way to okay, we have a lot of fucking errors. Yep, this is not correct. We could just say byte index star and byte index. Let's say we'll return a byte index pointer to a byte index. How to return an array in C? How to return an array in C? Fuck. Dude, I'm a fucking human. I don't have malloc. I know that I can dynamically allocate it, you fucking piece of shit. Ooh, we can allocate it as static. This is the best way. We could just take the return array from here. Far better, far better. Bit index allocated. Let's keep some big value. That is 1634384. And we pass that as results. Allocated. So we don't need any return type. No, the return type can be a bool. So we can actually do something. Yeah. Let's just go back to the original version. Okay, so this is the original version. Let's just run it once and it works. Now what we have to do is design another buffer that is bit index result. Let's just put let's just put 1000. No, we'll just put 64. We are going to only allocate 64 bits at a time. We don't allocate more than that. And we can pass that here, res, and res, and res, and you can just and we can remove all other stuff. That's it. Now we can actually write the extra thing, that is bit index star res, and it's going to pass that down to res. Here we again do the same thing, bit index star res, and we can here res of I equal to val. Hopefully everything is correct. Let's also figure out these error messages. There's lots of warnings, no errors. Uncompatible type passing 64 to bit index star. I think it's the same error like this. We just put what? Bit index star. Nothing much. Oh, how do we yank duck? Okay, I think we yanked it, and we paste it here and put a star. Okay, or we could just yank till end Um, and oh, holy fucking moly. And oh, God save me. Okay, I figured it out. It's just that I have to put press Y instead of U. That was the fucking error. What? Use type bit index where arithmetic pointer is required. Maybe I have to move it after the thing. Holy fucking moly. Maybe. Maybe I have to do it like I take the input, I cast it, and cast the bigger one. Okay, I fucking did not put star here. Well, let's see if we have one less error at least. No, we don't have that, so it's wrong. Cannot take address of R value of type. Okay, it's an R value. Maybe I just have to allocate it in stack. And just pass we need to pass an address to this array of bit index. Maybe so we don't need this entire bit index at all. That has been the issue. But I did get a warning saying I'm passing something wrong. So there is something wrong. What the fuck it is? That's what we need to figure out. Reset. This fucking thing still goes to again. Incompatible pointer type passing. We have a static array. me. And we are expecting a bit index pointer. What does that mean, Malik? Maybe, maybe. Because even here I got the same error. And I just cast it as this and the error went away. How the fuck? Get array as argument in C. See, this means exactly as the same as this because it's just the pointer to one. Because even if you give it as just array, it's just going to be a pointer to the head of that array. So why the fuck it's not working? You are making me rethink my fucking basics. Dude, this is the same fucking thing. That's why I have given it as bit index star because it's going to be a pointer to a bit index, and with that pointer you can just increment the next pointer to get to the next index. Why? How the fuck it's hard? Yes, it will decay into integer pointer. Pointer to integer. Yes, pointer to the first index. Then how the fuck my code says incompatible pointer? Like I get this value because this is like a static array and we are passing it to a dynamic. So I get that point. That's why I just dereference them. Like I specifically cast it to that. Cast it. Incompatible pointer types passing. So let's see. Maybe we could just give it like this. This would automatically give the first address. Looks like that. Maybe I was fucking stupid. Okay, so I was the fucking stupid. You could just give it like this. I was giving a pointer to a pointer. Oh my fucking god. Huh. I see. Here it works because I have allocated a structure here and I'm giving the address of the structure. But here there is an array and you cannot take the address of the array because array itself is just an address to the first pointer in the stack, first value in that array. Makes sense. So it's just me. It has always been me. I was the fucking... Okay. Now let's check if the result has everything. That's the next thing. For u in the 64 RTI equal to 0, I less than 64, I less than... If I put I less than 64, it wouldn't be correct. Would it be? Yes. It would be far better if we could return it like this. And we... bool if bool return 1. If it is not, then we return 0. If it is not, then we return 0. So we are going to return a u into 64 value. This way we could easily figure out what the fuck is happening. U into 64t. And we can write a helper. We can write a fucking helper. Holy it's just void. Oh, fuck me. Print bit index. And bit index is just going to take a res. Res is just bit index star res and size uint 64 t size, and we could just put print for uint 64 ti equal to 0, I less than size. I guess it's less than size, not equal to plus I, and we could put it here. We could printf and bit result. How do we type it? Index is index value is LLU, and bit is just X, and I can put slash. It would be res of index and res of bit. Did I do something wrong? I think it should fucking work. Okay, I'll just type it here. Print bit index res allocated CATD, and we'll yank one, and shit show, it's a shit show. Yank one. Okay, and I have to enter and put this. Okay, I got it. I can remove this. Yank one and type chuck, type chuck. Let's see. What the fuck? Oh shit. Allocated. Change it to allocated 1, comma /d. Good thing. Now it should work. What the fuck? What the fuck? What the? Where is this? 114? Shit. What do you mean 114? Where's my fucking 144? Okay, I have this fucking thing here. Where's the print index? Okay, it has worked. After we find the value, we have finally. Wait, first of all, why is there this many found indexes? Okay, found index is just it is going to go through everything. We have to finally check if an index. Let's just type this as okay, and we'll also add this. And we don't need this either. Where is set bitmap? We don't need that either. Now everything is printed from here. For the first attempt, we were able to get the indexes 0 and 1. For the second attempt, we got that. Okay, now let's try something bigger so we can try out bigger values. Let's try 7. No, we need to at least try thrice. So let's try 19,900. Let's see what happens. The first attempt has index 1, bit 1, bit 6, bit 7. What? Something is wrong. Something is wrong. What am I trying to allocate here? Let's just control fucking what? I / enter. Oh fuck me, I fucking forgot how to multi-line select and go here, and there is append text. Well, let's try this I enter / escape hints. Okay, I fucking forgot it. Well, we'll try one more time. It's just Control C, Control V. We select what we want to do. We go into this and we go to insert mode and we type what we want to type. Maybe it's this and press enter. Oh, fuck it. Oh, it's too much fucking work. Let's just put written 0 here. We don't have the energy to do it. Hopefully compiler won't say anything. Yeah, compiler did not say anything. Okay, fine. So we have a big value and we are trying to allocate that. If we try to allocate it, we must be here and it's not less than 4000, so we go here. We'll try to do this computation and we would have figured out a value. And we would have passed it down here. And here we would have tried to we have set it to true. So when even in the second iteration, we should not be getting the index as 0. No, bit as 1. Something is fucking wrong. Okay, let's just remove some prints to understand what the fuck is happening. We start the loop, we have index 0 0. We start the loop, we index and 0 1. For every iteration we have reached the third values, so we are going through it correctly. Maybe it's the value that is not properly set. Okay. Every time we get in here, we assign the bit index to index value and bit to 1, so it's correct. And we check the memory and we return I. and we set result of I equal to val. I guess let's also try to paste it here. The result index is val dot index and val dot bit. Let's see. World dot index. Well, where's results? Result is correct. Everywhere result is correct. So it's a memory bug because everywhere the result is correct, but finally when we are trying to print it, it's wrong. Okay, so how do we print it? We go to the first index. That's fuck me. How fucking silly. This is how stupid we are. Fucking stupid. What the fuck? See? Everything is correct. Shit. It's a shit show. A single mistake and we had to debug it again. That's how much trouble C is. Okay, now it's perfect. Now we could just remove this. Remove this return and test it for the entire thing. Yep, it's working. It's working. And why it's working? Because we have only two, let's say we have only two things, but we have allocated 6, because this alone will need at least 4 pages, I guess, and this needs 1 page. 4 plus 1 because we always add the page plus 1, so that is 4 plus 1 5 and plus 1 is the 6. Finally we have a working setup of managing the possible physical pages. So we found this low level helper can only do one thing. It can take an input bytes and it can allocate certain what's that certain pages, and it can give you back the index within that entire bitmap array. So the high level helper that we have to write probably next week is going to index into this and get the physical memory and use that to map it to the virtual memory. Yep, that's all it's gonna do. Perfection. Well. How long have we been fucking here? It's like 1 hour 20 minutes. We still have 20 minutes. Maybe you could write the. Oh, we still haven't finished the free version. Okay, we have only allocated things. We haven't yet removed that. Okay, so let's just do that part too. So in case let's say in case we have allocated something and we want to deallocate memory, in that case it has to take the main and it has to give the index. and bit. Mm, yes, I suppose so. And it should be a super simple one. Let's write it. Bool free index deallocate mem and it's going to take allocate mem and it's going to take an index and uint 8t bit. Now we have to deallocate it. What does deallocating it means? We just have to set the bit to 0, because if the value is set to 1, that means what does that mean? That just means the memory is being currently in use. So what do we do? We will do the same thing what we do there. We'll take it as temp buffer index. We take the index out first, and we want to also we need actually we don't need this, because we need a 0. And we shift the bits. Shift this to bit will 0. And then we can we also have to do one more thing, that is we have to assign that. This is what we have to do. Maybe we could also check if the bit is free or not. That would be, yeah. We could just check it like this. If check free, and it is going to take the same values. If check free returns, do we need to return false? If the temp bit is set to true, yeah, if it is returning true, then it is free. If it is free, we can do. If it is false, if it is free, then we return just true. It's already deallocated. If it is not free, then we take the index, we shift it to till that, and we put it back inside there. Mem buffer index and return index equal to v, and we can again do the same thing. If we reach here, we return false. I don't know why we should be reaching that point. We should never reach it, but we shall. I think it should be good. We have the we just check if it's already free or not. If not, we take the value, we shift the 0 to that particular bit, and we again check that same thing, and it should be good. I think here we don't even have to have this extra step. We could just simply return true, because this is also going to do the same thing. If it's free, it's going to return true. If it's not free, it's going to return false. So we don't need that extra step. If condition, we just return it like this. Now we write the main helper that is going to free everything from within the results. That is going to be interesting. Free free pages, I would say, and it's going to take a bit index array and uint64 t size, and it's going to do the same things. We could just copy paste it, but still equal to 0, I is less than size plus I, and then we could just print f. No. Why the fuck do I putting printf? Now we just have to free it. Deallocate mem. It will take. Okay, we also need the mem. That will be allocate mem star mem. We need the mem. We need the current bit index, so that will be res of I, and we'll need the size. What? No, we just need res of I of val, no, index, and res of I of bit. This is what we need. Okay, now we could do one more thing, that is just free it and print it again. Free pages. And it will be mem and res, and we could take this and print it after. So let's see if there is anything. What 129, what the fuck? Okay, I fucking should use the proper syntax. Free pages. What the fuck is wrong with free pages? Mem, result, and size. Okay, allocated 1. What the fuck happened? Let's try print it twice. It just prints the last bit. Maybe we also have to free the size equal to size. First we have allocated memory. Oh, okay. We have this extra allocation here. We also have to free that. Only then will be completely free. That's true. We could just say here uint 6014. Maybe now it will work. Yep. Now what exactly am I trying to do here? I have allocated something and I'm printing it and I'm trying to allocate it again. No, I don't want to do this. I want to allocate it, print it, free it, and print it. Okay, now let's see. We have allocated, that is 0, 1, 2, 3, 4. And we again print it. Holy fucking moly. Let's just try from this beginning. We don't know what the fuck is printing actually. So it should not print anything. That's fine. Now we'll just print the first one. Okay, that is printing that. Now we have to free those fucking stuff. If I freed it and if I try to print it, okay, I should not try to print it. I should try to allocate it and try to again print it. Okay. That way I know if we are reusing the proper things, because it must be free by now. That would be the perfect case. I think it is working, because if we improve it to 19900, we should get the same thing. Yes, we have allocated 1 2 3 4 and then we freed it and then we try to allocate again the same thing and we have gotten the same values. Okay, I think it's good. We were able to write a simple helper, like a low level helper that will use bitmap array to keep track of the physical memory and the physical pages, and the algorithm is super simple. We are just going to do it linearly and we're gonna go one page at a time and set the bits, and it works super fucking amazing. Okay, Okay, guys. Okay. Okay. Okay, well, when next week we'll try to implement the high level helper that will actually try to get some virtual memory from either from a process that's like a user process, or it could be the kernel is also like, because we just right now jumped into a va, and that va is like, if we go into where did we define that, I guess it's within mmu. And yeah, this is our virtual address, and this is the kernel. So in case if we try to jump, if we are already, if our kernel is already within this va, then let's say it wants some extra space, it will try to give us some virtual addresses. It's probably just going to be uh, paged 4 KB sized pages, and we just allocate certain physical pages and we map them. What we have to do is this, and we already have the code. It's like, it's super simple actually. What we have to do is this: we have tables, mm, we mark them as block descriptor. No, for the first, in the first layer we have to mark it as a table descriptor, and in the second layer we mark it as block descriptors. That way we can map the physical address to no, we map the virtual address to a physical address. So finally this is how it will be: we have a virtual address, and that will be mapped to a physical address, and the physical virtual address comes from the user process or the kernel process, and the virtual address comes from the user process or the kernel process, and the physical address comes from the bitmap array that we just wrote, because our mid-level helper is going to go into this buffer, and it's going to find the next free bit, and we can calculate if this bit is if this is the bit that is allocated for us. We can actually get the base address for this bit. It would be just adding 4000, I guess, because if a single page table can have 496 4 KB of addresses, so that's how we have to map it. Yeah, it's going to be a little bit of extra work, I guess, but I think we should be able to manage it. Okay, at least right now we could copy all this into our code and call it within the main. We could do that. Do we have time? We have 10 more minutes, so we could do that. Mm. Mm-hmm. Copy it and we put it inside the MMU or K-main. Where do we have the initialization? That's why we have to put this. Okay, we have it here, so let's just keep it here. And this buff is just it's this. Mm. That's it. I don't think we need any other changes, and we can just import includes std bool, and we should be good to go. Nothing much. And we don't have to have this here. Let's take this entire thing out of, and we can put it in kmain, because this is where we have allocated the memory. We have a bitmap, so we could just use it here and remove it. We remove this and remove that, and this is the helper that we wanted to write. Let's remove that, and we can change this to bitmap. And we can import this, and it should be in mem.c. So it's here. So maybe it will be super helpful if we write a new memu.h file and copy the stuff into that. And we also copy this. And we copy this. And we copy this probably too. And we could if def, how do we define I fucking forgot how to put if def in C. If def macro in C. Yes, it's just if def. No, wait. How can we stop a header file from getting included twice? It's just if ndef. I'll also put header. It'll be easy. MMU header. Now we can include it properly and we won't accidentally include it. CINCLUD EMMU. MMU.h. Even here we could just include MMU.h. And it's all good. Boom, boom, boom. It's done. Now we have the kernel initted and we have allocated the map and we have a bitmap starting address. We can pass that to this particular structure that we can hold, and we can allocate as many as memory as we want. This is just going to say that this physical page is used. Now we still have to do one more thing, that is actually map the virtual to physical address. Yeah, that we can do next week. I think it's good that we have everything is done correctly. Okay, thank you guys. I'll see you next week. Bye.